Alright, here we go again. Let's solve the tutorial Leetcode problem. So tutorial Leetcode problem is counting the number of commuter and login permutation. So okay, forget about the understanding of what is the permutation look like at that moment for now. That will be making us more complicated in the near future if we try to understand what is exactly the permutation look like. Just think like we need to count the number of commuter and login. So we are given an array of complexity of lunch n. Technically, we're just given an array that's involve all the complexity of array, and then there's n log commuter ins and rom. So the same size of the array of complexity, we have n numbers of commuters in the rom with a label of index from 0 to n-1, each with its own unique password. So the password of the commuter, each index has a complexity of the I. Okay, let's try to draw something else. Alright, I was trying to find the let's call like device. Right, that would be very tiny. Alright. Okay, that was a little bit struggle. See how? Alright, cool. So we have let's consider we have three devices, better name like device 1, device 2, D1 for device 1, D2 for device 2, and D3 for device 3. So we are given that the password for the commuter layer 0 is already decrypted. So we need to know that that is the index 0, index 1. That was a very terrible idea. Index 2. Alright. I better write with the... Okay, let me try to adjust a little bit based on that. So we will have a better control in the near future. I will try to zoom it out. Then that will make us very huge in the context. I'm gonna make it small. Okay, cool. Now make it small and I'm gonna zoom it out. Alright, perfect, 100%. So we are in here. So let's consider we have like numbers for index is like 0 index, 1 index, and 2 index. So we try to understand the question first. So this part of the question was done. So we are given a complexity of a lunch of n. Okay, just forgot about that. So we have given an input like 1 to 3, which is represent the D1 to 3. And then the password for the commuter layer 0 is already decrypted. So this device is totally decrypted. And then all the other commuter must be unlocked using it or another previous unlock commuter, the following information. So technically we can use this device to unlock this another remaining device in our given array. Okay, so each commuter also have, okay, let's consider like our given array like 1 to 3, 1, 2, 3, which is exactly similar to the D1 to 3 in here. I will just make it match in here. So we go into the given information how we can decrypt using the 0 index device complexity to unlock the remaining device. So I'm mostly focusing on the HTML1 in here. So we can decrypt the password of the commuter I. Let's say I is 2 in here. I. Okay, make it change to the orange color for better understanding. And then using the password for commuter J, that is where the J's come in. Where J is any integer less than I. So the value of J should be less than I. Technically, if we have a less complexity, that means like we have less complexity in the 0 index, which is a D1, That means less complexity mean like very easy to understand. So by using that complexity, we can fix the more complicated complexity. Yeah, that is the case. So we cannot say like difficult complexity or easy complexity. It's better to explain like if the number is small, that means like smaller complexity. Smaller complexity mean like easy to use. And so by using that, we can using the smaller complexity to decrypt the bigger complexity computer, which is D2 and D3 in our case. So where J is any integer less than I with lower complexity. So that is technically what I'm saying. So if that is the case, we can unlock the second commuter by using the D1. The same for the D3 since our complexity is still low. So the next step to decrypt the commuter for index, we must already unlock a commuter J such that J is technically less than I and complexity is also less than I. So we have to find the permutation of the 0, 1, 2, 3 up to the n-1 that represent a valid order in which the commuter can be unlocked, starting from the commuter 0 as the only initial is unlock 1. So since the number may be large, return is the modulo of 10 power 9 plus 7, we have to note that the password for the commuter label 0 is decrypted. So whatever we are given, our array of index 0 is as a decrypted version, not a computer with the first position in the permutation. So let's try to understand what is the permutation exactly meaning. So we are given like A, B, and C. What a permutation mean like? The ABC of this permutation is maybe B, C, A. Or maybe B, A, C. Maybe A, C, B. So anything can be possible. But by doing that, according to the given number, we are not allowed to change the first index, which is the 0 index. So we are expecting the value like this. That is the case. So another thing about the permutation is if the input is a 3, let's say the count is a 3, the output should be also the 3. So the output of each input and output of the count should be exactly matched. If they are not matched, that is not a permutation. Technically, we can see the permutation as a factorial in mathematical terms. Let's try to write the code a little bit so we will have a better understanding for that. So same as before, every time when I'm doing something, I'm going to create the mods to make us, we're not going to forget that in the near future. Let's call it mod. Technically, like we can write like this in the past, but I was explaining that about how can we write a better version in the Swift. So I'm going to use that approach also. Instead of writing like 10 with the 0 9s in the behind, I can simply create like integer with the 1e power 9. That is technically the 1 million. Not sure 1 million, just consider 10 power 9. And then we're gonna need the complexity of count. Let's call like let count is a complexity.count. Next step is let's call like result is a 0 initially. 0 for base key. I'm going to iteration through like for index in, I don't want to go through from 0 to the rest of the array because we are not calculating the index 0 for sure, since it's given here like the password for the computer with the label 0 is decrypted, so there is no chance for us to check. So instead of that, we better go through from 1 to the end of the array. So in here, what can we check is it is possible to unlock the next computer or not. How can we do it? We have two factors. One is a complexity of 0, that is encrypted version. Let's call like we have a decrypted value, which is a less complexity. That was our assumption. And then we are given like in here, if I is greater than less than j, we can unlock it. I mean, like j is less than I, we can unlock the second commuter. But there is a one and given case, like what if the two numbers are the same, like exactly the same? Like instead of like 1, 2, 3 in here, we are receiving, let's call like 2, 2, and 3. We are not able to unlock that because in that case, right, it's mentioned that we only can unlock if the complexity is less than the upcoming whatever the device complexity, so we can unlock it. So we need to think reversely in here. So I'm gonna write like complexity of I in here. So that is where we need to put the our condition flow. So I want to use that if condition as a base case. If we cannot solve it, just return the 0. That's done. And then just return 0. And then here I will be returning the answer, which is the result. So we're gonna define the complexity in here. How we can, which kind of like condition will make us not able to open or not able to decrypt the second index device. So it is like if our base complexity is greater than, meaning it's more difficult to understand for the base case and equal to our base case, then we are able to understand it. So next case, we just need to calculate the result in here. So if the result we receive, and then I'm going to multiply with the index and then mod with our modulo. But here is the one catch. Since our initial value of the result is 0, whatever we multiply, we stay receiving the 0 whatever the numbers coming through. So in that case, I'm gonna update the result with the 1. Let's try to run and see how it's work. What do I do now? Index in. Alright, that should not be the end. That should be the count. Alright, index. Alright, so many mistakes made in the one simple program. Alright, so that's the case like why we're gonna find any number of permutation in the isomer 2. You can see like our index 0, which is 3, is exactly the same complexity as index 1, index 2. There's no way for us to solve it. And then if it is not able to solve the upcoming commuter, we are not able to create the permutation for sure. That is why it is output 0. Yeah, that is how it's worked. And let's try to submit and see the Leetcode notation for that. So if I'm not wrong, we are receiving the time complexity of ON since we are just using the 1 for loop and from 1 to the end of the array. And then for the memory complexity, we're not using the any external memory, so it's O of 1. Yeah, that's pretty much it, and see you in the next one. Bye.